In this video, we're going to talk about how to charge an object, that is, create a slight imbalance in the amount of charge on an object. There are a couple of ways to charge something. One is called conduction, and the other one is induction. Conduction is the transferring of charge between two bodies due to contact. Keyword, contact. If the objects do not touch, then you are not doing conduction. Okay, this is very similar to the idea of transferring heat by conduction, and that's not by accident, because the electrons that freely move in the and carry the heat energy, the thermal energy, are also the electrons moving that are transferring this charge, usually in these conduction things. The second one, induction, is the influences of charges on a body due to a charged second body that is nearby but not touching the first body. So in this case, you don't touch it, so you're not transferring charge, but you're providing forces on those charges and causing them to move around. Hopefully this will be clear as we go through some examples. So let's first do conduction. We have an object that I show 5 positive charges. It's purely schematically representation. It could be any number that it is. And they're very far from this conductor. And let's say that this conductor is neutral. So by neutral, we mean that there is a net equal number of positive and negative charges. When this object comes up and touches it, some of these positive charges, for instance, might leave. Let's say the 2 get off. When this now is pulled back, there will only be 3 charges here, and there will be 2 positive charges over there. Notice charge must be conserved. Charge is neither created nor destroyed, only transferred. So the number of charges before, 1, 2, 3, 4, 5, still have to be the number afterwards, 1, 2, 3, 4, 5. Now, you can have 7 plus and 2 negatives. Remember, these showing 0 is really not 0. There are pluses and minuses. So if a plus was to leave, it would leave behind a minus. The plus and the minus together equals 0. When you add up those numbers, they better stay the same in each one of your drawings. That is charging by conduction. Here is induction. Induction is what I did in some times with a can. If you rub a PVC pipe with some fur and you stick it near a can, you can actually pull the can across without touching it. And the reason is by this thing called induction. Here you have positive charges, and here's our neutral conductor, and I've actually shown the plus and minus charges in it. Equal amount, so it has no net charge. When you bring the rod close to it, these positive charges repel the positive charges. So it moves those positive charges back here. At the same time, it attracts the negative charges toward it. Now here's the thing. The distance now between the plus and minuses is different than the distance between the plus and plus. And the further the distance, the weaker the force. So there's now a net attractiveness, because these opposite charges are closer together than are the charges that got repelled. This is especially true for conductors' metal. Why conductors? A conductor says that these charges are free to move around. If these charges were not free to move around, then they wouldn't redistribute like this. So you need something, for instance, like a metal can. Now, you can pull it close, and this net can will actually accelerate toward this object. So if it's going this way, it'll slow down. Or if you pull it this way, you can actually make it speed up. Try it. It's a lot of fun. Now what happens if you pull this bar back? As you pull that bar back, the forces that it's applying upon these charges is less. And these charges are also experiencing a force between each other. In fact, it was balancing that out. So as soon as you pull this back, these positive charges will move back over, these negative charges will move back where they were, and you'll end up with something that looks like it did when we started the problem. So it doesn't permanently charged. You won't get electrocuted or shocked. But it does experience a force provided this rod is close. Now, you can charge by induction. And it's a really neat trick. If you don't know the trick, it can almost seem like magic. So let me show you the trick. In charging by induction, we're going to connect this neutral conductor with a wire to a ground plate that has lots of charges. And by ground, that's all we mean. Some big conductor that has so many charges that if we take one or give one, you practically can't tell it. It's like Bill Gates losing a penny, if you would. So, again, all neutral. Got a wire to this ground. Has lots of plus and minus charges here. Plus, minus, plus, minus, plus, minus, plus, minus. You bring this thing in now close, this positively charged rod. And what happens? Well, negative charges are attracted, just as before. The positive charges are repelled, but in the past they were stuck on the sphere. Now they can move down this wire. Maybe one of them has already made it down there. So they can leave through this wire to get further away. Now, we think of positive charges as moving because that's just the convention that was set up. In reality, a lot of times with a metal, it's negative charges moving up. The negative cancels the positive and makes it look more negative. Either way, whatever it actually moves, the net effect is this object becomes more negatively charged. Now, if you just pull this rod back, these charges would get pushed back up and this would be neutral. So what we're going to do is we're going to break the highway now. While keeping this close by, we come up and we break the wire right here. So I've got this object that's got negative charge on it. The opposite charge of what this is charged. Now when I pull this back, because the wire is broke, the positive charges can't go back up. And I leave the object with some charge of the opposite sign of the object that you brought close. An example of something that uses this technique is called a Wimshurst generator. They're giant lightning shooting machines. Look on the web for a video. They're really cool. Like I said, this is a lightning machine. Something that uses the conduction principle to move things up is a Van de Graaff generator that we use for large nuclear accelerator experiments such as in my lab. Alright, that covers conduction and induction charging. I'll see you on another video.